This is section 1.3, algebraic expressions. I'm going to split this video up, or split this section into two different videos. So this video is simply the notes, and then I'll make a separate video that you can watch if you would like to that works through all of the examples in your note packet. First, we need to just go through some vocabulary. A constant is a letter or symbol that represents a specific element of a set. So specific is the important word there. This never changes. So usually that's going to be represented by a number. A variable, however, is a letter or a symbol that represents any element of a set. So variables are going to change between the different problems. We're going to start looking at polynomials. A polynomial is just the sum or the product of monomials. Remember that word right there, poly, just means many. And then we have some special names for different types of polynomials. You need to be familiar with these names just so that when you hear them, you can immediately think of what we're talking about. So a monomial is just one term, a binomial is two terms, a trinomial is three terms. After that, we just say a four-term polynomial, five-term polynomial, and so on. Next, the leading coefficient. The leading coefficient is just the coefficient of the monomial with the highest power or the highest degree. That leads us into degree is the largest exponent. When we factor, we're going to, the factors are smaller polynomials that make up the product, and then a prime polynomial is something that cannot be factored. With polynomials, we're going to focus on the four different operations. So first, with addition, we're just going to combine like terms. For subtraction, I think the easiest way to do this is to change all the signs of the polynomial being subtracted. Now usually that's going to be the second polynomial. With multiplication, we're basically just going to distribute each term to the other one. Now in some classes we talk about FOIL. Remember, FOIL only works when it's a binomial times a binomial. If it's anything else, basically you're just going to distribute each term to every other term in the other polynomial. And then finally, division. We're going to make individual fractions and then reduce each one. Again, on page 5 of your notes packet and the top of page 6, there's a bunch of different examples. I encourage you to, you can try to work through those on your own, or you can watch the other video that's going to work through those examples also. Next, some specials products. Basically, this is just trying to save you guys a little bit of time. So if we have a binomial where it's the exact same stuff in both sets of parentheses, but one is addition, one subtraction, it's just going to be the first thing squared minus the second thing squared. If we have a binomial squared, okay, remember that means we're going to take the binomial times itself. The easier way to sort of think of this, you can write it out and then FOIL it. The easiest way to think of this is x squared plus, this is the important part, 2y plus y squared. I think most people get the x squared and the y squared. That stuff makes sense. But then that middle term, make sure we double it. Make sure we get 2xy. With subtraction, the exact same thing happens, except for that sign is going to stay, or that sign is going to be a negative. Now, if we have a binomial cubed, this one is really, really helpful because writing it all out is not a whole lot of fun. So what you're going to see is first the coefficients kind of go in order. They go 1, 3, 3, 1. Okay, and then next we take this x term. This x term goes x to the third, And then this one, the degree is going down. So x squared, x to the first. This one's really x to the 0. And remember, anything to the 0 power is 1. So I'm going to erase that guy. And then for the other variable, for the y, we're basically just going to go backwards. So this is y to the third, y squared, y to the first, y to the 0, and again, anything to the 0 is 1, so it's going to go away. Now our signs, when it's addition, are always positives. With subtraction, it's the exact same setup, except for your signs flip-flop. So we start off with a positive, we go positive, negative, positive, negative. And again, looking at one of these examples, I think that you'll see example 5C in your notes. This property, this setup makes it so much easier than writing out, for example, 2a minus 5b times 2a minus 5b times 2a minus 5b and multiplying it all the way through. That's not a whole lot of fun. Okay, next we're going to look through factoring. Basically, factoring just goes through and undoes everything that you just spent a whole lot of time multiplying out. There's really 5 different types of factoring that we're going to focus on. The first one is taking the greatest common factor. This is what you should do when you start every problem. So if there's a common factor, and what we mean by common factor is just something in common from every single piece of your polynomial, go ahead and factor it outside. Now the difference of squares, here's what it looks like. X squared minus y squared. Okay, we know that's the difference of squares. X squared is a perfect square. Y squared is a perfect square. When we factor them out, we're going to go x plus y and then x minus y. Now what I want you to remember, and you'll hear me say this a lot as we're working through stuff, this is the good times and the bad times. Okay, what I want you to think of, it's kind of a little story here. This is a couple, right? There's 2 people involved in a couple. However, they're going to break up because the relationship is not going well. It's a negative. Now, when they break up, obviously they have the bad times. They each take part of themselves and they have the bad times, which is represented by our negative here. But hopefully at some point in time during their relationship, they also had good times. So they still take those individual good times back with them. So just a quick little story there. Next, the difference. This is the sum and difference of cubes, actually. This works for both of them. So x to the third plus y to the third, and then also x to the third minus y to the third. Okay, with this, we're going to remember the acronym SOAP. Now, SOAP stands for same, opposite, and then always positive. Now, the way we're going to remember this, it's going to have 2 factors. The first factor is just the exact same thing, the x and the y. And you'll see it's actually the same down here. So the setup is the same. The signs are what's going to change. We're going to use SOAP there. Then in this middle, we're just going to go x squared, xy, y squared. And then we go SOAP. So right here, this is the same sign as the original. So there's a positive, there's a negative. This is the opposite sign. So this first one was a positive, which makes it a negative. Down here in our difference of cubes, this was a negative, which makes our opposite positive. And then here, always positive for our last sign. And again, this one, the difference of cubes and the sum of cubes especially, just makes your life a whole lot easier, because otherwise guessing and checking, you're really going to struggle with that. Now, these 3 types of factoring are sort of special cases. So if you get a problem that fits into one of these, we're going to go ahead and use one of these methods. Now, if it doesn't fit, we're going to end up just having to guess and check. So with guessing and checking, if A And remember, this is when we're looking at something a squared plus bx plus c. That's what I'm talking about with the a, b, and c. If the leading coefficient is a 1 right here, we're going to look for two numbers that multiply to c and add to b. Now, with your signs, you've got to be really careful, and there's some sort of things to remember here. If c is positive, okay, there's a couple different ways that c could be positive. Either we could have a positive times a positive, or you could have a negative times a negative. So if you see that c is positive, that means that those two numbers that you're thinking of either both need to be positive or both need to be negative. If c is negative, that means you could have a positive times a negative or a negative times a positive. Now, if a does not equal 1, these are a little bit more challenging. What we want to do is find factors of a and factors of c. Then you only have to check the O and the I, the outside product and the inside product of your FOIL part. Because in this first step, you already figured out that the F in FOIL is going to work, the L in FOIL is going to work, so you're just going to check the O and the I. And unfortunately, there's not a good way to do these quickly. It's really just if you happen to get the right number first, you're set. If not, then you just have to erase it, start over. And then the last type of factoring is factoring by grouping. So first, we're going to factor out the GCF from the first and second terms, and also the third and fourth terms. Okay, factoring by grouping only works if there's 4 terms. Now, once you've done this, you actually have about the same answer. The leftovers should be the same. And by leftovers, I mean the stuff that is still left inside the parentheses after you factor out the GCF from the first and second, and then after you factored out the GCF from the third and the fourth. So whatever those leftovers are, that's one factor. And then the other factor is the 2 GCFs that you factored out from step 1. All right, so those are all the notes from section 1.3 algebraic expressions. Again, I encourage you to also watch the video of me working through examples. That example video is not required. So if you want to skip around and go through certain parts or certain examples, absolutely, that is fine.